Assalamualaikum dear students. I hope you all are doing well. This is your tutor Ms. Javeria Mas and I'm back with another video lecture. I hope you all remember that what we have studied so far. So students, what we were doing in previous lecture, we were studying regarding angular momentum. We have already studied that in detail. We have studied regarding its definition, how we are supposed to find its formula, and also how do we can find out the angular momentum for each of the coordinate, let's say Lx, Ly and Lz. Now as I promised you all that in today's lecture we are going to study regarding SI unit and dimension of angular momentum. First of all, one should know what SI unit is. So keep in mind, SI unit is basically the standard international unit. So what does it mean? It simply said that the unit that is accepted internationally. Okay, so how we are supposed to find out? Students, it's a very simple and very easy method how we are supposed to find out SI units. Keep in mind, we are using the formula to find out the SI unit of angular momentum. Not only SI unit of angular momentum, to find the SI unit of each of the physical quantity, we should use, or we actually uses its formula. So let's start it. We know that the formula of angular momentum is L, that is equal to Rp, that is momentum, and this is linear momentum. So we know that R is momentum and its SI unit is what? Meter. Keep in mind, meter. This is SI unit of radius. Okay, and we know that further P is equal to linear momentum mass into velocity, and the SI unit of mass is kilogram and the SI unit of velocity is meter per second. So let's put this in equation number 1. Okay ji. So before putting these two, what we are going to do, let's write P into NP. Okay, we know that meter is the SI unit of R, and the SI unit of linear momentum is kilogram meter per second. Okay, so let's put it over here. Meter, the SI unit of mass, kilogram. Don't confuse this M with this M. Keep in mind, this is meter, SI unit of R. This is mass, quantity of the quantity that is included in linear momentum. Mass for kilogram, and for velocity we have meter per second. We just put the SI unit of each of these quantities that are present in angular momentum in the formula. So what we do, meter into meter multiplied and becomes as meter square, whereas kilogram and second remains like this. Okay, or like this. Now what we are going to do next, in order to make it or simplify it more and more, what we are going to do, we are just simply simply going to multiply and divide second over here. Okay, can we write these meter square like this? Meter kilogram into second square. Let's say these two multiplied and gives us a second square, and this one remaining meter into second. Can we write like this? We can. And why we are doing so? We are going to just simplify it more, and in order to simplification we are doing this process. Okay, so we know that meter kilogram per second square is equal to Newton. Okay, so meter kilogram per second square is equal to Newton. We write it as N capital, and meter second remains like this. Also, we already know that Newton meter is further equal to joules. So replace this Newton and this this meter as joules, and second remains like this. So the SI unit of angular momentum is joule into second. Let me just give you all a quick review what we have done. Keep in mind, first we are going to see the formula of angular momentum, that is equal to R and P. R is radius, P is linear momentum. We put the SI unit of R, that is meter, over here, and the SI unit of mass over here, and SI unit of velocity over here. By simplification, we got meter square kilogram per second. What we do in order to simplify it more and more, we just multiply and divide second with this expression. By multiplying, we got second square in the denominator and kilogram in the numerator. We just break down this. We just write meter into meter separately, like meter 1 here, meter other with this second. Okay. Why we did this so? Because we already know that meter kilogram per second square is itself equal to Newton. So we wrote it Newton and meter second as it is. Then we already know one more thing, that Newton meter is further equal to joule. So we simplified it more, and joule into second. This is the final and SI unit of what? Of angular momentum. This is very much not simple, but this is not very much hard as well. Keep in mind how we are supposed to find out the SI unit, how we are supposed to find out the dimensions. For both of these, we just need the formula of the physical quantity. Also, these two things you can't remember while cramming. You should practice them in order to become more and more smart in finding out the SI unit and in finding out the dimensions. We should practice it as more as you can. Now the dimension. Keep in mind, for dimensions, L is basically the symbol that we use to replace the SI unit of any quantity that has meter, like length, radius, etc. And and for kilogram, for mass, any quantity that has been measured in kilogram, we replace kilogram with mass. And any quantity like time, definitely time only have a SI unit, that is second. In order to replace second, we use T. Let me repeat myself. Keep in mind what we are doing. We are just replacing meter with L, capital L, kilogram with capital M, and second with T. That says length, mass as for kilogram, and time as for second. So whenever we talk about any quantity that have SI unit meter, like your length, radius, etc., we use L. And for quantities that are having SI unit kilogram, we put it in dimension, or while doing dimensions, as capital M, that indicates mass. And for time, we replace the second, what means to say SI unit second, with the T. Okay. We know that the the formula of angular momentum is Rp. We know that radius is one of the length, and it is one dimensional, So we write it as L. Let's do it in Budov work sort of, so that we can easily do it. Meter per second for velocity, kilogram for mass, and for radius we have meter. Okay. Kilogram has been replaced by capital M. Here is meter per second. Meter should be replaced by capital L, and second should be replaced by T. L into L becomes L square, M remains same, and T remains same in the denominator. Or we could write like this: L square, M, and T inverse. Inverse means to say this is in denominator. When it comes in numerator, it becomes -1, or the minus signs come over here. I hope you do understand how we are supposed to find out the SI unit and dimension of angular momentum. If you have any sort of query regarding the topic, you can do write any query in the comment section. Also, if you want to make me video of any specific topic that you are having difficulty with, or that you are not understanding properly, you can do ask me to make the video on it in the comment section. Please do subscribe the channel and do like and share the video with your friends. Allah Hafiz till the next video.